All right, so we already had in LLMOps space, we already had some pretty interesting and great events. I think we've yet, I'm guessing at least most of you have heard about them, so it's really an honor to have them here, and especially Zain. So we're going to talk today not about the regular search and RAG, et cetera, with the vector database, but a lot more focus on the multimodal search where we're still using the same types of techniques, but we will get the angle that's kind of unique for when you have more than one type of data. So I mentioned earlier to introduce yourself, ask questions on the LLMOps space Discord. In general chat, I'll be there live during the event, taking questions from there. A bit about the community. So LLMOps space is a global community for LLM practitioners. We have quite a lot of events, kind of like this meetup. We focus on content discussions and events. And the idea is to gather there are larger communities in the world, right? There are communities of tens of thousands of people. But the idea is that this is kind of all around one topic, which is LLMs and getting LLMs into an application in production. So what's pretty cool is that all the conversation is around that. So we're doing all sorts of things like making lists of the different consultants in the space and the products. And we're enabling something here, which if anyone here wants to reach out, we can look into this for significant product launches. We're also going to have events that are designated for announcing them here. So pretty cool community. Thank you all for being part of it. Just want to give a bit of an update about what happened this area in LLMOps. So we started to see comparisons with the Claude 3, not just the whole model family. There are different ones. I actually never trust these comparisons very well, so they're being compared and showed how they beat GPT-4 and so forth. But until I kind of see hands-on exactly what was done and kind of play with it, then I don't have I don't trust it 100%. But there are blogs out there that are saying that it's top notch and that it's kind of beating some things that are considered state of the art. So Snowflake and Mistral had a new partnership or announced a new partnership. I think they already have existing partnership through an investment, and Snowflake is doing quite a few interesting things in this area. And Accenture had a significant partnership with Cohere. I'm not saying that the other one isn't significant, but here I think it's something around a $3 billion investment one way or another. I know the terms are always more complicated, but Accenture are taking significant steps in the space and kind of relying on Cohere. And then something else which happened, which is really interesting, is Cognition Labs released Devin. Hope I pronounced it right. Which is an AI software engineer that does complex tasks. What's really cool about this is if you go onto their website and look on their blog, you'll see quite a few, very kind of explainable videos that show like short videos that show like how it does all sorts of different tasks. So it's pretty hands-on, and you can get a feel for it. Of course, videos are always a bit demo-y, so if you manage to somehow try it yourself, and of course that's the best. So yeah, so here, just to kind of remind, there are a lot of great companies and products out there, and part of the goal here in these events is to try to map everything, is kind of have an organized place where you kind of understand what's happening. And if you go back and like just watch all the videos or see I think this is our 11th meetup. So if you just watch the 10 leading up to this and this one and continue, that it's kind of supposed to be built like a syllabus. So you'll understand, a lot about the space if you just end up kind of going through them. But anyway, there are always new ones, so we'll definitely update this once in a while. But yeah, it's kind of worth mentioning. In terms of consultants, so we have an area that talks about consultants. I know a lot of times these projects are like either one-offs or really, really quick projects that you have to that you have to do kind of from today to tomorrow. So I think it's a great place to reach out and kind of learn about them. We also kind of force them to put or we request from them to put in their price range and so forth. So some things are a lot more accessible than other places. And that's it about the community. A bit about the agenda for today. So Weaviate is based on open source, which is pretty amazing. Anything that's based on open source, I always like to give it much more stage, definitely in a community like this one. So we're going to be talking about open source vector databases, understanding multimodal embedding models, discovering cross-modal search and so forth. And yeah, we're also going to do real-time cross-modal retrieval. A bit about our speaker today. For me, you know myself, you know me probably if you were at least one other event. My day job is CEO at DeepChecks, but I'm also moderator here at LLMOps space. At DeepChecks, we do continuous validation or evaluation of LLMs and AI. And today you're going to be hearing mainly from Zain. That's it was a founder in the past, and now he's a developer advocate, which I think requires a lot of the same qualities. And it's really cool to see how the great job that Zain and his colleagues are doing, which I'm sure is they're gaining from the things he's done before. And today, we kind of talked about what he's going to be mentioning, but I think it's pretty unique, pretty special, and there isn't that much content about it yet out there. So just about future events. So if you're interested in speaking, or if you have colleagues that are, that you think would be great speakers, then either reach out or refer them, please. And that's it. Over to you.
Awesome. Let me do a quick screen share here. Let me know when you see my screen. All right. So, Philip, you see my screen?
Yes. I raised my thumb. Sorry about that.
Ah, okay. Sorry, it's not showing up on the other side here. Okay,
Uh,
cool. So, I'm going to be talking a little bit about multimodal search with vector databases. As Philip mentioned, Weaviate is fully open source, so you guys can get the source code here. I'll talk a little bit more about that as well. But I wanted to start off just by showing you what I'm going to be talking about, what the end product of this talk is, right? So here's an app that we built on top of multimodal search and multimodal retrieval. So I'll just play this for you and shut up so you can get an idea.
we just, okay, let's do the video, and then we'll start with the survey, and then we'll do the first survey.
All right. If you want to do the survey, go ahead.
Yeah. Okay, great. We're just starting off with, we'll have a couple of surveys. So we're just going to start off with asking a very basic, just to get the audience a bit. So we're going to ask, what's the stage of your current LLM app, conceptualization and design, development and testing, production and deployment, or optimization and scaling. So I'll let it run a bit. So how about Zan, you continue, and then I'll stop with the results of one slide later. Sorry for the interruption of the bad timing.
Yep, sounds good. Okay, cool. So what you saw in this app was multimodal search, right? You've got this little search bar at the top here, and you can put in text, but what you get out is multiple modalities, right? You got video, images, audio files, and we played some of those for you as well. How is this actually working? A lot of people think when I show them this demo the first time that we're searching over some metadata, right? I've took some text description of the audio, the image, or the video, and that's what I'm searching over. And then I'm just pulling out the video that's affiliated with that text, and I'm showing you guys that. Um, that's not actually what's happening. The text is being searched across the contents of the video, the actual audio file itself, the image itself, right? There's no metadata here. In fact, the only thing that we have for these files are IDs that are in the names, right? We don't really have any metadata. So we're doing direct search from the query to the content, right? So and in this talk, I'll talk about how that's even possible and how this works with a vector database.
All right, I'm
Okay.
ending the poll here just so we can have a quick view. I'll do the share results. So we can see 48% are in conceptualization and design, which is pretty early. Development and testing is the majority here, 56%. Production and deployment, 17%, and optimization and scaling, 7%. I see this really depends on the topic sometimes, but in this case, development and testing is definitely the funnest phase, right? So it's great to have the majority be there, and yeah, it's a good time to hear kind of early on or during the first one or two use cases to already hear about some of the more advanced topics like this one.
Awesome. Right. So I'm not sure if people can raise their hands, but usually what I like to do to start off, I think that in this setting, you might not be able to raise your hand. Oh, you can raise your hand. I see it here. So how many people here know what a vector database is? And here I'm seeing a lot of hands go up on the other. Okay, cool. Um, let's just leave it for
Yeah, we had 33 at the peak, and now people are low.
33. Okay, cool, cool.
Raise their
So
hand.
33, yeah. So I've been trying to run this poll for, I've been at
Out of
Weavy for,
out of 80 participants. I just had to say that because before that we said 50 something. So
yes.
when it peaked a
Yeah.
bit, it was really fun.
Yeah, I've been running this poll for about a year and a half, and when I started this poll off, I used to get like 1%, 2% of the hands go up, and so 30, 40% of the hands going up is quite a lot now, right? So we've come a long way. There's still a lot of work to be done, right? So I'll talk for 5 minutes maybe to bring everybody up to speed on what vector databases are, and then I'll jump into the topic of multimodality, right? So I usually like to start off talking about how a vector database differs from a normal database, right? So a vector database, like any other database, can catalog, store, retrieve information. That's what it's there for, and it can do this at scale. The only main difference here is that a vector database does retrieval based on this concept of similarity, right? And this is a bit of a fuzzy concept, so I want to dive a little bit into this, what I mean by similarity, right? Um, a NoSQL database also does a retrieval based on similarity, but it does it based on text similarity, word similarity, right? And that's not the similarity that I mean here. So what happens in a vector database is that you can take all of your data, and this can include your emails, your text documents, videos, image files. Those go through a machine learning model, and the job of this machine learning model is to convert your data into a vector, right? So every object that you have over here gets turned into a array of floating point numbers. So if you have a billion documents here, you'll have a billion vectors here, right? And then there's some arrangements where you can even have a multi-vector setup per object, and a lot of people are exploring that right now, and you can do that with Weave8 as well. But once you've got a vector representation of your data, you can now plot that out into your vector space. So every object is a dot here in my 3D vector space. Usually this is much more higher dimensional, 1,000 to 4,000 dimensions typically. But here I'm just showing a three-dimensional representation. And the main concept here is that similar objects are going to be closer together, right? So the word and the image chicken are going to be closer together, whereas the banana and the cat are farther apart. This is the main concept to think about in vector space. And so really what's happening is you can almost think of this as a big library where you pass in your data, it gets classified. If you think of a Dewey Decimal System in a library, it tells you where to put the books, right? If you have a book on philosophy, that's going to be located in a particular section of the library. If you have a book on the arts or engineering, that's going to be in a totally different location. So depending on the concept of the data, it's going to be located at a different location within your vector space. And so really a vector database is just a gigantic library, and the vector search engine is a superhuman librarian who can retrieve concepts, retrieve books for you in real time, even though there's billions or trillions of data objects in the database. So let's have a look at what this retrieval process looks like.
Just
So
like
now
one
that we have,
Just
yeah,
one thing
go
we
ahead.
can think about. I think to me at least it sounds kind of like that, except instead of having like one sticker, then it has like I don't know, N stickers, like 10 stickers on them, and then each time you can kind of search by a different type of sticker, maybe. Anyway, maybe I'm overcomplicating,
Yeah,
but
exactly.
all right.
So now if you've got all of your data in the vector space, now what you can do is you can have a user that comes in and brings in their query, right? So let's say this is their query, and their query can be in natural language. This is one of the reasons why language models work really well with vector databases. Vector databases can be queried in the language that language models speak. So your query can literally be the string cute fluffy kitten, and that's going to be found in this kind of neighborhood of vector space because this is where the animals are. You have cats and dogs over here. And retrieval is basically looking at which what is in the proximity of your query, right? So you've got green objects over here, and you can retrieve the closest ones, the closest nearest neighbors, and that is what you'll show to the user. And so if you think about the whole vector search pipeline, you start off with this encoder, the machine learning model. You pass in your data. You take the data and you store it into a vector database. You take the user's query, you project that into a vector space as well, into the same vector space using the same machine learning model. And when you do that, you get out a list of ranked results from your data that are the most semantically related, the closest to the input query. Right? And so this is how a vector database or a vector search pipeline differs from a SQL or a NoSQL pipeline, right? So in a SQL pipeline, you would use a SQL filter, whereas in a NoSQL, something like MongoDB, you would go ahead and do a keyword search. Here, you're actually using a machine learning model's understanding of your data to find concepts that are close versus farther apart. And so a little bit about Weaviate, it's fully open source. We've been around for a while. We've been around for the last 5 years. Um, a lot of interesting customers. You can have a look at it. I've also linked the GitHub page at the bottom here if you guys want to have a look. So let me dive into what you can do with Weaviate.
Wait, I'll just launch already survey number two.
Cool.
Okay, so launching about what are you currently using for a vector database? Obviously, not everyone here has a vector database yet, but just if we're talking a bit about Weaviate for a second, I will
Hmm.
state in general in LLMOps space, we usually request that speakers talk about if something's open source, they can talk about it freely, and if something's closed, then we say that it's fine to talk about it because it's always practical, but always to try to give a few different alternatives. So I think it's pretty, when it's definitely some of the things that we do to of course, to emphasize that open source rocks, and it always has a lot of advantages when it's possible. All right. So
Open source indeed is awesome.
yeah, so the options here for the survey that's happening is open source vector database, which is Milvus, Quadrant, or Weaviate. We have, and of course, there are other ones like Chroma and so forth. Proprietary vector databases like Pinecone, or just not using yet a vector database. So those are the options. And yeah, I think maybe we can end the poll already. Actually, I think people answered pretty quickly. So let's share the results here for a second. So this is pretty cool. I
Wow.
I didn't know that actually. The most common now is open source vector databases. Uh, I think something that I see is pretty interesting that's happening is kind of starting off. There were a lot of folks using the closed ones that are considered kind of best practice, and
Mhm.
then some of them got these like tiering systems where the free ones or the very cheap ones they have like some limitations on the not you could have like one index and things like that, which makes it like kind of work for some things but doesn't work for some other things, and then even for the quick kind of POCs, then sometimes just starting off with one of the open source ones is already a bit easier. I think like now a lot of companies, once they decide they're scaling, then they think about, do I want to do managed or whatever open source I'm used to
Yeah.
versus going to one of the hosted ones. I'm not sure this is all over the market, but I've seen this a few times.
Yeah, this is a good point, actually. Maybe I can spend a couple of minutes on that. One thing about the open source vector databases that I like is that you've got a lot of flexibility in how you want to deploy them, right? It's not just a managed version. You can deploy it on-prem. You can deploy it within your own cloud. You can deploy it in your own cloud and let us manage it. There's a lot more flexibility, and I think production requires that flexibility. So I think we're seeing that. That's super interesting. Awesome. Right. Uh,
But I will state that compared to the other machine learning, like I don't know, compared to traditional machine learning or non-generative, or there's not a great name for that yet, right? So I do see more, even of the more traditional companies, somehow working with SaaS or selling to OpenAI and Azure. So somehow the on-prem barriers in some cases has been broken, but still there are quite a few companies that say, okay, I can send my data out to
yeah.
OpenAI, but I shed blood and tears to get
Yeah.
that approval, and then for anything else, I'm trying to avoid it when I
Yeah. Yeah. And I think that will change as we get more open source alternatives in the field that are equivalent. Um, but I think it's mainly due to the limitations of creating these massive models. And more companies are open sourcing. We saw that Cohere open source their Commander model yesterday, which is super exciting. Um, yeah, I think we're trending in the right direction. It's going to be great. Yeah.
Right, right. But I can tell you, it's hosting the open source models is still hard. It doesn't really solve it. Sometimes, going with these solutions that where you get a managed version of an open source model and play with it so that then later on you can
Yeah,
consider moving. So there are all sorts of solutions of that sort, but
yeah,
it's tough and it's expensive. I don't know if it's going to be solved that quickly.
yeah, yeah. Awesome. So now
Right.
I'm gonna jump into multimodality, right? So the idea here was to lay the groundwork for understanding what vector databases are. A lot of people use vector databases right now to search over text semantically. So like I said, it's basically a librarian that can understand what you want and understand what's in the library and get you exactly what you want. Um, but this talk is not about that. This talk is more about how vector databases can handle a lot more than text. So if you've got images, audio, video files, you can also search over those at scale with a vector database, right? And so this is where multimedia data comes in, right? And the motivation behind this is to do with how humans actually learn, right? So if you think about how kids that are younger than a year learn, they don't really speak. They do a lot of learning through interactions, right? So they'll touch things, they'll feel things, they'll smell things. So a lot of this foundational learning is multimodal. It varies across the senses, and it's mainly non-lingual, right? So we lay the foundations of our knowledge on this multimodal learning, and then we build on top of it using language as an abstraction later on in our life, right? And so we'd like machine learning models to be able to do this as well, especially learn from different modalities, right? Text is a discrete modality. We want them to be able to look at images, video, audio files as well, and learn from that as well, right? And the demo that I showed in the beginning, you can do this cross-modal search where you pass in text, but you get anything back that is related to it, not necessarily just text, right? And so the promise of multimodal models really is this idea that you can pass in your question or a concept that you're interested in to this vector space, and then whatever is the most closest in similarity in concept to this will come out, right? Whether that be text, so you can do text to text search, or even if it's an image, you can do text to image search, audio search as well as video search. And this is the premise of the app that I showed at the very beginning. That, by the way, is also open source. I'll post a link to that so you guys can build it and play around with it as well. But it doesn't stop there, right? You can actually do any-to-any search. Your question can be in any modality as well. So your question can be in text, but you can also pass in an image as a query, right? And the idea here is when people are building recommender systems, if I like shoes that are of a particular style, my query can be that image of that shoe, right? You can have audio files as input, video files as input, and then depending on whatever is most semantically related, you can get out any other modality as well, right? So now you have the flexibility of any to any search where you can ask questions and get answers in any modality. And so in order to be able to do text to any search or any to any search, what we did with Weaviate is we integrated multimodal embeddings, right? And these are embeddings that a lot of companies are providing increasingly now, more so than about a year ago. But we integrated Facebook's Meta AI's multimodal embedding model, ImageBind, and this model understands images, audio, video, text, and even actually accelerometer data from your cell phone. So there's a lot of different modalities it understands, and it unifies them. So you can look at vectors across modalities and you can retrieve across modalities as well, right? And so once you have this vector space, what you can do is essentially take all of your data, regardless of modality, as long as the model understands it, you can pass it through, and the text encoder, which used to be independent of the image encoder and the audio and the video encoder, are now all binded together, meaning that if you have a concept that's similar in any modality, the vectors will also be similar, right? So what I want to point out here is that the vectors are quite similar because the originating concept of the data is also quite similar, right?
That's really
And
cool.
and so this is like the main machine learning model that powers that multimodal search app that I showed at the beginning. And this is also this app that we built is open source, so I'll send you guys a link where you can play around with that.
Right. You know, something that's pretty interesting I'm thinking about just now. So a lot of times, what kind of drives what people think about what's happening with a LLM based app or something like that is kind of driven by the everyday products we're using, and of course, ChatGPT
Yeah.
is one of them.
Yeah.
So at least I'm with their Pro account or whatever it's called, and it's embedded that you can kind of generate images as you're talking. So there's like the image generation component. I think in
Yeah.
some cases the like search the search is part of kind of the with from a RAG from a vector database or vector search with a regular database. So it's it's sometimes it's interchangeable in terms of the user experience. So you say, okay, look, I'm trying to look, I'm writing something for my family. I want to create something at work. Can you help me do this and this? So it could be
Yeah.
searching for images, it could be creating new ones. But I think for some things, RAG is like a lot more useful, right? Like let's just take a use case of I don't know, Schneider Electric, and they have some sort of electrical appliance and now we
Yeah.
want to fix something. So if there's a RAG that gets like the correct diagram, and then it's explaining to you in text what the nuances of the right. So that
Yeah.
type of thing, I think we're uh, centuries away from that being generated at a high enough level.
Yeah.
But when you're doing a good job with a RAG, it sounds very hard. But when you're doing a good job with it, that's like really, really, really useful stuff
Yeah.
that and the use case is a bit different than just kind of saying, yeah, here's like that lion example is probably more for like something between fun and things like that
Yeah.
when you think of the use
Yeah.
case.
So when you want to actually, and we can, if you have any questions, just post them in the Discord. I can have a look at them later. For production use cases, really what you want to do is not just rely on a image by itself, because like you said, unless the image is very general purpose, it'll be difficult to retrieve it exactly. If you have schematics or flowcharts or diagrams or tables or something like this, then what you really want to do in production is use a multi-vector approach. So you want to store a text. Let's say you've got a caption for that image. You want to store that. You want to store the image. You want to store any metadata that you have, because then what you can do this with VBA. I'm not sure about the about other vector databases, but you can then do multi-vector search where you can say retrieve retrieve the objects that match on this particular text, but give me the image, or retrieve the objects that match on text and image and give me this back. And so this brings back a lot of the search relevance that you're used to with text-based retrieval augmented generation into the multimodal retrieval augmented generation. And so in production, you have to rely on kind of semantic similarity of text description as well as the image description as well as metadata there to do a lot of filtering. Awesome. So once you've got the capability to do multimodal retrieval, first of all, you've got a knowledge base that is multimodal. You can store in all of the different modalities there. You can do a lot of cross-modal functionality, right? So you can do cross-modal retrieval, so you can play a sound and see what comes back as a as an image, whatever modalities you've got stored, you can store in there. Um, you can also do interesting vector space arithmetic, right? And so this was popularized with the king minus queen example. That was text arithmetic, but now that you have multimodal embedding space, you can actually do multimedia arithmetic. You can say, what does this image plus this audio sound uh, retrieve, right? What video or image does this retrieve? And these are examples from the image bind paper, the modality that we integrated into Weaviate to enable the app that I showed in the beginning.
There was a question. I'm answering more of the questions on Discord, or kind of referring to them than over here. But there was a question in the chat over here about which paper you implemented. So it's here. It's here at the bottom.
Exactly, it's right there. Image bind. This is from Meta AI. This is quite a powerful multimodal embedding model. This is not the only one, but practically this is one that works great. Yeah. Right. So a lot of people think that they want large language models, and you hinted towards this. Like ChatGPT initially was just a large language model, um, but quickly people are realizing that what we actually want are large multimodal models. We want them to be able to not just understand the language that we're typing in, but also understand the images or the audio files. So with Google Gemini now, you can also pass in audio files. Um, and so people are beginning to realize that as we go towards more complicated applications, we also need these models to understand a lot of this multimedia data that we can retrieve from our knowledge bases. And so I wanted to talk a little bit about just the applications of multimodal models and vector databases, right? If you can have these multimodal models that understand your data, and then you've got these vector databases that can scale up retrieval to the billion scale on this multimodal data, then what can you really use this for in industry for applications? And so probably the
So
yeah,
with that question is a great time for the third and last poll. In the meantime, so I'm
awesome.
launching it, which is what's the primary use case for using a vector database. So the options are text search, multimodal search, recommender systems, RAG, or other. Wow. Okay. I'm not even gonna say why I said wow because you're gonna see the results soon. But you can probably guess. All right. So I think continue for a bit
Yeah,
and then we'll kind
okay.
of go off.
Yeah, this one's exciting. I'm looking forward to this one. All right, awesome. So I'm going to talk about two examples here. The first one is improving e-commerce recommender systems. So let me lay the groundwork. So right now, a lot of e-commerce recommender systems, and a lot of you might know this much better than me, they're based around text-based search. What that means is if I go to Amazon or Shopify and I click around, they'll look at what I'm clicking on and they'll look at the text description and some metadata of that, and they'll use that to filter what else they kind of filter up and recommend to me, right? So if I like a particular shoe, they'll look at the description of that and they'll do recommendation based on that description, right? Um, if you now think about multimodality and this multimodal retrieval that I've been talking about, you can revolutionize this field, right? And this is where I think the majority of the applications are. Um, so if you think about how
Wait, just
how
one sec, just
yeah,
one second. I know you were in suspense, but I'll share the results of the last quiz. So you can see,
RAG,
yeah, the
yeah,
beginning I could see that it was like well way above everything else. Then the other ones kind of got at least some of it.
okay,
I think it is multi-selection. So a lot of those using RAG are also doing other things. But
yeah,
so text search is 32%, multimodal search or multi-modal search is 20%. Where I should mention we do have selection bias just because that was the title of the talk, right? So it's probably
yeah,
less of the general population. Then our recommender systems, or recommendation systems, 23%, RAG 78%, and other 2%. So I think we did expect RAG to be dominant, but at least at the beginning it seemed even more
yeah,
dominant than I would have
yeah.
imagined.
That's awesome. I like the bump in multimodality, and we're seeing this in our daily interactions as well. As you get these capabilities, you get embedding models that are multimodal, and you get generative models that can understand those modalities. People are now saying, okay, I can solve this problem not using text. I don't have to force the data through a text modality. I can actually use the data as is, right? Um, and e-commerce recommender systems, which was high up there as well. Is probably the prime candidate to use this first and foremost. And the reason why is because of this question, right? So if I ask you what type of burger do you like, um, you can answer me in multiple ways, right? You can go here and describe the burger to me, and this is typically what companies use right now. They use text-based search to do recommendations, but this is a very small part of, my likes and dislikes. I can also show you the burger that I like, right? And you can learn a lot from an image of it. Maybe in the future, you can't do this right now, but maybe in the future, you can actually give me an understanding of how that burger smells, right? And there are actually companies, if you're interested in this, there's a company called Osmo that spun out from Google that is actually capturing smell as a vector and then projecting that into vector space and then allowing you to do search on it. So this is not science fiction. It might sound that way, but it's not. Um, you might also have audio sounds, right? And so now you can take the user, you can take your customer, and you can understand their likes and dislikes along all of these vectors of modalities, right? Images, text, audio, smell, all of these. And not only that, but there's also work that's being done on capturing tabular data as a separate modality, right? So you can have your nutritional information about your products, and this can be metadata as well. Um, that can also inform what your customers like and what they don't like. And that can be captured now in this vector. But the problem is that you don't want to limit all of these modalities to one vector. So what we did with Weaviate is we enabled multi-vector search, right? So you can actually represent an object using as many vectors as you like. We call it the named vector approach. You can say burger image, burger text, burger nutrition, and now you have three different representations of the same object through its three modalities. And now you can perform cross-vector search, cross-modal search across these three representations of the same object, right? So you can say, rank for me the best looking burgers based on this person's preference, the best described burgers and the most nutritional burgers, and then you can do this re-ranking across modalities, which is quite powerful.
Wait, so am I getting this, like, I just want to see if I missed something or not. Could I just take like many images of the same object and then also have them be like, different vectors for this? Like,
Exactly.
wait, so
Exactly. So you can take like a front image, side image, top image, and they can be separate multi-vector representations of the same object as well.
yeah, I know that in the military, there's a problem. It's really hard for like if you have an image of a building from one area, they just recognize it it's a different image from a different area. It's like almost like completely different information. So I think what's interesting here is because the whole beginning of the talk you were about, oh, now look, there's this cool new embedding method where everything kind of is represented by one vector, and here you're back saying, oh, we have multiple representations. But basically, what you're saying now is no, it's kind of like different images, right? It's like one idea, but there are different representations where they could come from an image, they could come from multiple images, they could come from a smell, whatever.
Yeah.
But just because you can represent it with one vector doesn't mean you want to. You might want to have different ways
Yeah.
to kind of hook onto it.
Yeah, there's two approaches to this typically. So the image bind paper takes this and it allows you to generate multiple vectors. And then depending on your vector store, your vector database, it'll either allow you to store all the vectors or it'll force you to squish them together into one vector, in which case you would do some sort of averaging, right? You would take 70% of the image vector, 10% of the text vector, and maybe 20% of the tabular vector, and you would join it together into one vector representation if you've got a single vector database. But if you've got a vector database that supports multi-vector, then you can actually store the three vectors that are generated by image bind, and then that will give you much more fine-grained search over your data. You can choose which modality you want to search over, which is a lot more powerful.
Yeah, actually, here I've lost a bit because are they all in this method from the Facebook research method? Shouldn't they all be in the same space? I think there's also a question here in the Discord that says, does that mean you can do similarity comparison across different multi-vector spaces, or the comparison is for each vector space?
Yes. So if yeah, that's a good distinction to make. If you're using that Facebook multimodal model, because it's the same vector space, you can do cross-modal search. So you can pass in a text and you can retrieve images, right? But that's not on that's a limitation for that model, or that model allows you to do that. But with this multi-vector approach, you can actually take models that are completely different for text, completely different for images and tabular data, and you can generate these three vectors that have nothing to do with each other, and then you can perform within modality search. So you can say, here's an image, now give me other objects that are similar in image. And so there you would only be able to do image to image search because not every model understands cross modality, but the meta one does. So with meta, you can kind of amplify the powers of this multi-vector approach where you can say, here's a text, now search over the text embedding or search over or these this multimodal embedding. Yeah.
Right.
But the multi-vector, yeah, go ahead.
What sounds like it might be a limitation with this approach is that you have like missing values, right? You could have objects where sometimes they have only an image or only the text or only this and that, and then it's like,
Yeah,
okay, so so if you don't find a way to kind of translate between them, then you could, then
yeah.
it'll work. It's just less elegant.
Exactly. So if you've got data that's messier where you don't have one modality, then having separate uh, machine learning models is not that useful because then you'll have products that don't even have a representation across one modality.
Yeah.
That's where the multimodal approach is good because you can at least take the vectors and add them together or average them. That way you'll at least have a vector across the modalities for that object. This single vector approach where you've got one image vector, one text vector, one audio vector, there you if you don't have an image, then you can't do that. Will never be returned because that has no representation in your vector database. Awesome. So this is one area where we're seeing a lot of interest in the realm of recommender systems. Another area that I think is quite new, and this is because a lot of our generative models did not handle multimodal data, and now we're seeing this over the last couple of months with GPT for vision and Gemini that has vision and audio. Lava is the open source equivalent of these that is visual instruction tuned, but a lot of these models that are generative can now understand images as well, right? And so now people are saying if our vector databases can handle multimodal data and our generative models can understand that data, why don't we take RAG and turn it into multimodal RAG, right? So the idea behind RAG really is the model doesn't know anything that hasn't been trained into the parameters. And this is a lot of data. There's a lot of enterprise data that is private that the companies don't have access to, so they can't really train on it. And so the answer is quite simple, right? RAG is quite simple, and 70-80% of the people here are using it. So I'll kind of um, skim over this. But the idea is you've got a retrieval engine that you select filtered documents from, and then you pass it to your language model to reason over. It's more of a read then generate type of approach. Right? And so now your response is a lot more customized, right? And that's basically the simple concept of RAG. The reason why you want a vector database for this, typically you can use any database. You don't have to use a vector database. But the reason why you want a vector database is because the language model can actually do self-querying of the database, right? So the query can come from the language model. It doesn't need to come from a user, which is quite useful, right? So here, you can have this approach where you can take your concept that you're interested in, you can hit a vector database that is storing potentially billions of objects, and it'll give you the top three objects that are the most relevant, and then you can go ahead and send that off to your language model, and it'll fire off a customized response.
By the way, there's I think a good question from Badir in the Discord
Mhm.
asking if we can control the significance of a specific modality. So if you have a few different modalities, can you say, yeah, I want to give more weight to text or more weight to images? So
Yeah.
that works.
That's a really good question actually. So there's a couple of ways that you can do that. One way is to do this vector summing approach, right? If you've got a multi-vector database, you can say I only want to do image search or text search. There you're basically giving zero weights to the other modalities that you're not searching over. Um, or let's say you do all three. Let's say you've got images, images, audio, and text. You do all three searches, and then you get a list of rankings that are returned for objects in those three realms. You can do re-ranking, and you can overweigh a particular rank, and that way you can give that modality more heavier weight. Classically, how this was done in the past is because a lot of vector databases were limited to a single vector approach, you could say I want that single vector to be 70% image vector and only 30% text vector. And you could do reweightings there. But now that you have a multi-vector,
When you're averaging, because people would average all the time. So
exactly.
we just do like different weights. Okay.
Exactly. But now that you have a multi-vector approach, you can fire off three separate searches and then you can re-rank them afterwards, right? Which is a lot more nuanced. That's a lot more powerful. The other interesting thing here is that you can do a lot of interpretability work afterwards as well. So there's papers that are being released around using Shapley values to understand how important is a modality. So if you think about it, if a customer is purchasing a product, you might want to know why they purchased that product. Was it because of the way it looked? Was it because of the brand? Was it because of a description of it or a video or something like that? So people are also exploring. I'm not seeing any of this in production right now, but I think that over the next couple of years we'll see a lot of this. But people are trying to understand which modality do you want to weigh more, right? Because it's not always a easy answer. You can actually look at use machine learning interpretability techniques like Shapley values to understand whether people are buying a product more because of its image modality, the way it looks, versus the way it's described, or the fact that it's a Nike brand or an Adidas brand or something like that, right? That's also another kind of avenue that relates to this, but is under development. Okay, cool. So this is the RAG use case, but um, a lot of people are now asking this question. Um, if our knowledge bases can handle more than text and our reasoning engines, our language models, and our multimodal models, the generative models, can handle a lot more than text, why should we just stop at retrieving text? Right? We can go ahead and retrieve anything. We can retrieve videos, audio files using vector databases that can store them. And then we can take the modality that comes out. Here I'm showing an image, but if your language model is Gemini, you can also retrieve audio files, and then you can send it off to your large multimodal now. Notice how the L changes into an M. So now this large multimodal model can understand multiple modalities. Now you can even reason over things like graphs from papers or financial graphs, flowcharts, tables, all of that kind of think of it as semi-structured data, I guess, can now be reasoned over with your large multimodal models. Right? And so this is a lot of work that we're doing internally at Weaviate to support this type of search where um, kind of introducing multi-vector approaches, integrating with large multimodal providers like GPT-4 Vision, Gemini, all of these, so that now you've got the entire stack in one place, and you can do this end to end with the same vector database. And so that's really everything that I had. If you guys want to try this out, here's a QR code. I'll leave it on this page. One more thing that I'll do, we've got a very vibrant community, a lot of people. Uh, if you want to join us, please come to our Slack channel. If you have any questions, please put them in Discord. But if you want to talk to me afterwards as well, you can reach out to me on my socials as well. I'm always happy to talk. And I think we've got some time here. Philip, let me know if there's any questions. I'd be
Yeah,
happy to take live questions.
I think we'll take like two questions. There are a lot of questions. Again, I was giving priority to questions in the Discord. Apologize. I think Emma Chorfa, I think you asked many questions here in the Q&A. We don't take questions from the Q&A here. It's hard for me to manage both.
Mhm.
We want to enable kind of continuation. So any questions that came up here weren't asked in the Discord, please ask them in the Discord. And Zain promised me he'll go back to the Discord and also answer questions and kind of be engaged. And so hope to see the discussion continue there. So next question. So first of all, they said to please send the QR code here. I know I'm speaking louder to try the Weaviate, but I will do it. So here you go. Here's the QR code for those of you in the Discord who want to try Weaviate. So the first question I want to ask is a question from 1 second. Yes, Security Ninja. So when we convert audio, image, text through encoder, will it have similar or same vector score when we want to retrieve all of them as response?
It depends on your modality actually. So the way that these models are trained, um, you have to have training examples that allow you to understand the different modalities. So for example, if you think about a YouTube video, it's very easy to bind that because it comes with image frames, video, audio, as well as a transcript of it, right? So you can bind all of those modalities together. And if you're searching over those concepts, they will be closer together in that vector space. But let's say you've got a modality that's not very easy to bind, right? Let's say you've got images of astronomical images of planets. How do you bind that with sounds? That's not very easy. So if you've got a undertrained region in latent space of these models, then it might not be similar. But as long as you're using these multimodal embedding models for general purpose kind of use cases, general purpose domains, oftentimes the vectors will be close together. This is one of the reasons why we can use them to do multimodal and cross-modal retrieval. If you want to use them for more special purpose domains, you'll have to curate your own database, your own kind of data set, and then fine-tune the models to understand what does similarity mean when I'm talking about images in astronomy or something like this. The general purpose models are not good enough for that.
All right. Okay, next question. So the question is by KK7 in Discord. Sorry if it might translate to more explainable name here. Are you able to achieve the same using open clip embeddings? And how do you compare open clip to image bind? Or do you think image bind is better? So feel free
Yeah.
to that you didn't play around with OpenClip or whatever, but that's the question.
Yeah, for sure. So I think there's pros and cons. So image bind, I think, is a better model because it came out a lot later. It's a model from like 5, 6 months ago. So of course it has better representations and it's been trained on more data. Um, but it's a lot heavier as well. It's a beefier model, so it takes more to deploy that. Um, OpenClip, if you're only interested in text and images, I think going with OpenClip is good. But ImageBind, for example, understands audio, video, a lot more modalities as well, right? So if you only want to do text and images, you can go ahead with OpenClip, Clip, and I'm sure you'll get really good performance. We've actually integrated Clip as well into Weaviate. So if you go to our docs, you can actually see multi-DevEc ImageBind as well as Clip, and you can play around with those. But it really depends on what modalities you're interested in. You know, if you're only interested in text image, I think OpenClip would be my choice because bind is a lot heavier actually. So yeah,
All right, so we have many other questions. A lot of them were asked in the chat here. Please, anyone here, please ask the same questions in the Discord, and Zan is going to put some time to go and answer all the questions. It was a pleasure to have you. I think it was really interesting, and I think it also touched a lot of topics that aren't in like the mainstream that everyone talks about now, but they will be. So I think that's exactly what we're trying to do here. So thank you so much for coming. Hope to host you here again or meet you at other events. And for anyone with questions, please take the extra step to ask them on Discord and see you there.
awesome. Thanks everybody. Take
Bye.
care.
And
Bye.
I think it's worth subscribing also to LLMOps Space on LinkedIn and so forth, where every time we have a new event, we'll also publish it there. All right. See ya. Bye.
See you. Bye.